The following equation shows Kepler's third law of planetary motion. It relates the time t in days that a planet takes to revolve once around our sun to the distance d in kilometers of that planet from the sun. So it tells us t, how many days, and it's in relation to the distance that that planet in kilometers is from the sun. Mars is approximately 4 times as distant from the sun as Mercury is. About how many times longer would Mars's revolution time be than for Mercury? Round your answer to the nearest whole number. So let's think about it a little bit. If you increased d by a factor of 4, what's going to happen to t? Well, if you increase d by a factor of 4, you're going to, notice you take d to the third power. So if you replace d with 4d, you're going to get t squared is equal to 3.98 times 10 to the negative 20 times 4d to the third power. Well, 4d to the third power, 4 is going to be the same thing. I could rewrite that as 4 to the third times d to the third. 4 to the third power, that's 16 times 4, that's 64. So it's going to be the same thing as 64 times d to the third power. Or I could just write this as d to the third power, and then all of that times 64. Now, we have to be careful here. We might say, hey, look, this expression on the right side is 64 times this expression right over here. When we increased d by a factor of 4, the right side becomes 64 times as big, because remember, 4 to the third power. If this becomes 4d, then this becomes 64d to the third, which we saw right over there. But on the left-hand side, you have a t squared. So over here, you would get that t is equal to the principal root of all of this business right over here, the 3.98 times 10 to the negative 20 times d to the third. Here you're going to get t is going to be equal to the principal root of 3.98 times 10 to the negative 20 times d to the third times, you could throw the 64 into the radical, or you could say times the principal root of 64. Well, the principal root of 64 is 8. So times 8. So when you look at it this way, you increase d by a factor of 4, you're going to increase t by a factor of 8. This expression is the same thing as this expression, but we have a times 8 here now. So about how many times longer would Mars' revolution time be than for Mercury? Well, 8 times longer.